So as we continue talking about angles and lines, let's talk about lines cut by a transversal. And, you know, what angle relationships are formed when parallel lines are cut by a transversal? And that's what we're going to be talking about. That's us working with the ability to solve for angle measures when parallel lines are cut by a transversal, or to complete the steps to prove angle relationships given parallel lines cut by a transversal. So we're going to be talking about some theorems, and it's going to be corresponding angles theorem, the alternate interior angles theorem, alternate exterior angles theorem, and then of course the same side interior angles. So with some basic definitions, a transversal is a line intersecting two or more coplanar lines at different points. So looking here, line C is a transversal of lines A and B. And I did forget to include they are parallel. So there's looking at a transversal and what they do. And then as we develop the theorems or look at the other theorems, we need to keep in mind that, well, this straight angle formed by a straight line is going to be 180 degrees. And with that 180 degrees, we know then that angle 1 and angle 3 would be a linear pair. And we know that another relationship of angle 1 and angle 4 would be vertical angles. So just bringing those things back and realizing that we're going to be working with them now, and they're going to help us with a lot of things. For you, okay? Good luck. So as we talk about corresponding angle theorem, corresponding angles, a corresponding angle would be an example of angle 1 and angle 5 in relationship to the transversal and our parallel lines. Angle 1 have the same, we'll call it location, right? The top left, and so they are corresponding, looking at just this angle. Angle 1 is right here, looking at this, this intersection, looking at this intersection. Angle 5 is right here. So 1 and 5 are corresponding. 7 and 3 are corresponding. Angle 2 and angle 6 are corresponding, and angle 4 and angle 7 are corresponding. So corresponding angles. So if a transversal intersects two parallel lines, the resulting corresponding angles are congruent. So again, we have two parallel lines cut by a transversal, and they're going to tell me that, according to the theorem, that my corresponding angles are congruent. But let's look at this. And if we just look at from the information that we know about angles, looking at this, we know that, again, this is a straight angle. So I should know that angle 1 plus angle 3 is going to be equal to 180 degrees. Okay? And I should also know that angle 1 and angle 4 are vertical angles, so they're congruent. And angle 3 and angle 2 are vertical angles, and they are also congruent. Well, that tells me, looking at that little bit, that angle 3 and angle 2 are congruent. So over here, if I just think about angle 2 is congruent to angle 3 is congruent to angle 2. I also have angle 1 is congruent to angle 4. All right, so if corresponding angles are congruent, so if our corresponding angles are congruent, since our angle measure here is going to be the same as the angle measure here because my line is parallel, that is going to tell me then that technically angle 1 is going to be congruent to angle 5. Okay? If angle 1 is congruent to angle 5, well, we know, because what do we know about angle 5 and angle 8, right? these are vertical angles, so they are also going to be congruent. And then, of course, if I'm looking at this and I can tell you that angle 5 is congruent to angle 8, which is congruent to angle 1 and angle 4, that means angle 1, angle 4, angle 5, and angle 8 are all the same measurement. So with that, correspondingly, I could say then that my other angles, my vertical angles, angle 6 and angle 7, are going to be vertical angles, and they will be congruent. So we have the same relationship building there, that angle 2 is congruent to angle 6, and angle 6 is congruent to angle 7. So we're able to say that all of those things are going to be congruent. So outside, let's see here. So corresponding angles theorem says if a transversal intersects two parallel lines, then the resulting corresponding angles are congruent. So that will be useful for us in the future. Sure to get them answered. Now, if we talk about alternate interior, and alternate exterior angles, well, let's just put some of the stuff back in place that we were looking at in our other drawing, our previous slide. So these are A and B are going to be parallel lines, and C is our transversal. And that tells us that our vertical angles are congruent, corresponding angles are congruent, and again, vertical angles are congruent, and then corresponding angles are congruent. So I was able to do that, and now let's look at the alternate interior. So we're going to start with our alternate interior angles. So when if a transversal intersects two parallel lines, then the resulting alternate interior angles are congruent. So if I look at this, let's just say alternate interior. Okay, well, interior, these are my interior angles because they're inside the parallels, right? And then my alternate interior angles would be 3 and 6 because they are on alternate sides of my transversal. They are inside the parallels, so alternate would be 3 and 6. 4 and 5 are alternate interior angles to each other. And if we just look at this, by its congruency, we know that 4 and 5 are congruent because they have one, congruency hash. 3 and 6 are congruent because they are doubles. And if we just did some math, we know that 1 and 3 added together would be 180. So that means 3 and 4 added together would be 180. And then 5 and 6 added together would be 180. So it seems to be the measurement of 5 and the measurement of 4 are the same. Let's see here. So alternate and interior angles, angles are congruent. And looking here, the alternate exterior angles, okay? Alternate exterior angles, so outside of my parallels. Alternate exterior angles would be 2 and 7. Those are alternate exterior angles. 1 and 8 are alternate exterior angles, and alternate exterior angles are congruent. And we can see that in our markings, that 1 and 8 are congruent. 7 and 2 are congruent. So again, it looks like the alternate exterior angles are congruent. So these are useful tools, and we can see when we went around and did our corresponding or our congruencies, we were able to do a lot of those, identify a lot of those values and properties, and just went back and verified, that they are true. And when we talk about same side interior angles, okay, we know that this thing, right? We know that this angle is equal to this angle is equal to this angle, Those are just vertical angles. And then we know that all corresponding angles, so 1 and 5 are corresponding angles and they're congruent. Well, then that makes 8 congruent to 5 because it's a vertical angle. And corresponding 2 and 6 are congruent, and then 7 would be congruent because of, or 7 is congruent with 6 because it's a vertical angle. Now we want to talk about same side interior angles. Same side interior angles are going to find out that they are, well, let's see here before I just say it. Angle 1 plus angle 2 equal 180 degrees. Then angle 1 and angle 3 equal 180 degrees. Well, if 1 is equal to angle 5 and 1 plus 3 is 180 degrees, if 1 is equal to 5, then isn't 3 plus 5 also equal to 180 degrees? So what we're learning here is, and let's see here, if we have angle 1 plus angle 3 is going to be equal to 180 degrees because they're linear angles. And I know that angle 1 is congruent to angle 5. Then I know then that angle 1 plus angle 5, angle 3 plus angle 5 would then equal 180 degrees. So again, so here my same side interior angles are going to be equal to 180 degrees. Remember, interior, inside the parallels, and same side are going to be equal to 180 degrees. So again, we know that angle 3 and angle 5 is equal to 180. So that tells me that angle 4 plus angle 6 is equal to 180 degrees. And that's that same side interior angle theorems. So we, using several theorems that we're applying here. For an email. And then, okay, as we examine what we have here, so figure number 1, let's go ahead and we can see that line M and N are parallel to each other, and the transversal is going to be line L. And those three things are going to be facts for all of these diagrams. But we can see that the angles identified, hopefully you were looking at these right here, and you are telling me that these are going to be corresponding angles because they're in the same orientation to the transversal and the parallel lines. So corresponding. 2, these are going to be on opposite sides and they are going to be inside the parallels. So those are alternate interior angles. 3 here, these are going to be same side exterior angles, and we haven't talked about that yet before now, but a alternate exterior angle, these are same side exterior angles, sorry. Same side exterior angles are going to be supplementary. Interior, same side interior angles are going to be supplementary. And then alternate exterior angles are going to be congruent. So let's see here. These are alternate exterior angles, and they are going to be congruent. Number 4 is going to be same side interior, and those are going to be supplementary. Then we have what appears to be same side exterior angles, and these are going to be something same side exterior, and those are also going to be supplementary. Number 1 here, we have corresponding angles, and those are going to be Hopefully you remember that those are congruent. And then we have alternate interior angles in number 2. These are alternate interior angles which are going to be congruent. So alternate interior angles congruent. So those are just some characteristics of our angle pairs and relationships. All right, so if we take an example here, and we're going to end up working with 4 lines, not parallel here, right? We just got 2 lines right here. But then we're going to have parallels here. So these are going to be parallel. Put in my little parallel markers. And then if I go ahead and label some of my angles, just so we have them for reference. And I want to know that the measurement of angle 3 is going to be equal to 120 degrees. The measurement of angle 12 is going to be equal to 80 degrees. And so what the heck does that mean? Well, let's go ahead and label some of that here and see if we can figure it out. All right, so let me see here, angle 3, so we're talking 80 degrees. And then angle 12 is going to be, sorry, I just did that backwards. Angle 3 is going to be 120 degrees, and angle 12 is going to be 80 degrees. Well, if I just look at these, I know that just by the fact of linear angles, we know a linear pair is going to be 180 degrees. So if 3 is 120, I know that 40 is going to be 60 degrees because linear pairs are 80 degrees. Now, if that's the case, I know that angle 4 and angle 1 will be congruent, so angle 1 is also going to be 80 degrees. I know that in this case that angle 1 and angle 5 are corresponding angles, and corresponding angles of parallels cut by transversal are going to be congruent, so I know that angle 5 is going to be 80 degrees. Well, if I know that, then I know this is going to be 80 degrees, and then of course my linear pair to those, angle 7 and angle 6, is going to be 120 degrees. Just filling in the blanks as I go, and oh, I forgot my my vertical angle to angle 3, angle 2 and angle 3 are going to be the same degree. If I come over here to the other side of the transversal and I look at angle number 12, well, I know 12 and 11 together will be 180, so then 11 is going to be 100, right? 180 minus 80 is 100. So 11 and 10 are going to be 100, and correspondingly 15 and 14 will also be 100. So we have 80 degrees, we have 100 degrees, we have 80 degrees, 80 degrees, 100 degrees, 100 degrees, and you can even look and say, hey, well, look at that, my same side interior angles are 180. But if I go back to that original side that I was working with, clearly I made some mistakes here. If angle 3 is 120, that means angle 1, 4, 5, and 8 are not 80, they are 60. Ooh, goodness. You know, it's late, and I'm just getting tired, I think. So let me fix that. All right, so we were able to fill in the blanks going around that. And that's, you know, the expectation is that you guys can do that by just knowing the definitions and what they are to be able to fill those in. So let's look at some mathematical. I want that page yet. I want this or the page here. So some examples using algebra, right? That's what we want to do. And of course, examples. Let's see here. So if I have another set of parallel lines, cut by a transversal, and of course get my stuff in there, and we'll just call this line A, C, and B. And I know that the measure of angle 1, I don't have any angles on here yet. Let's go with 1, 2, 3, 4, 5, 6, 7, 8. And I know that the measurement of angle 1 is going to be 3x plus 10 degrees. And then the measure of angle 4, so angle 4 is going to be 4x minus 15 degrees. And then what is the measure of angle 7? So I'm trying to find angle 7. Well, I know by the virtue of a vertical angles are congruent. If that's the case, I know that these two guys are going to be equal to each other because they're congruent. So I know that angle 1 is congruent to angle 4. And then if I do some substitution, I know that angle 1 is equal to 3x plus 10 degrees, and angle 4 is equal to 4x minus 15, and then I do some substitution here, and then I know that 1x is going to be 3x plus 10 is going to be equal to 4x, which is 4x minus 15, and now I solve. So I'm going to subtract 3 from both sides, and then I'm going to have 10 is going to be equal to x minus 15. Go ahead and add 15 to both sides, and then x is going to be equal to 25. There you go. There's x. Now that's not the measure of angle 7, right? Angle 7 is the same thing. Angle 7 is the same as angle 3, and I don't know angle 3 yet, but in order to find out angle 3, I'm going to have to find out one of these guys. But what I can do is I did find out the value of x, so I can plug x back in over here to figure out what angle 4 is. So angle 4 is equal to 4x minus 15, which, doing the substitution here, is going to be 4 times 25 minus 15, which is going to be 100 minus 15, which is 85. So I know then that angle 4 is going to be 85 degrees. If angle 4 is 85, so is angle 1. And then if angle 1 is 85 degrees, that makes angle 3 95 degrees, and then correspondingly angle 7 would be 95 degrees because of corresponding angles. So that's just using the information that they've given me to, deductive reasoning to figure out everything else. Grab me in class. All right, so looking at this example, it's asking me, what is the value of x? Well, I don't think I have. I have some kind of interior angle, exterior angle, alternate. No theorems work there, but I can go ahead and use some corresponding values here. Let me identify, yes, this was meant to be parallel. That corresponding angles, this angle right here is going to be corresponding to angle below it of 15 degrees. Now, if I go ahead and fill those in because of corresponding degrees, I know that, or corresponding angles, I know that this straight angle is going to be equal to 180. So I can turn around and say, well, if it's all equal to 180, I can say the angle of this angle plus this angle is going to be equal to 180 degrees. And then I can solve. So that's going to be 5x plus 120 equals 180. And then minus 120, minus 120. We have 60 is equal to 5x. Divide both sides by the coefficient. That is going to be x is equal to 12. Now they didn't ask me. Did they ask me for the value of x? They did. Thank goodness. It's going to be 12. But we could have plugged it back in here and said, okay, let's see if it works to give me the other values. All right, so here I have another possible example, right? And so I have two parallel lines cut by a transversal, and this angle is going to be equal to 2k plus 11 degrees. And then the opposite exterior angle is going to be 131 degrees. Well, if they are recognizing as the opposite external angles, well, then I know then that they are supplementary. So 131 degrees plus 2k plus 11 is going to be equal to, not 180. They are going to be equal to one another because they are congruent. And if that's the case, then we can just go ahead and solve. Minus 11, that is 120 degrees equals 2k divided by 2, and then k is going to be 60. So we're just applying those definitions that we've been using in two numbers and solving for the equation. Relatively easy. So if you have any questions, so working with these lines cut by a transversal, knowing we did need to understand perpendicular bisector, perpendicular lines, parallel lines. And this shortest distance theorem, yeah, we can go ahead and get rid of that because I was actually taking that from the wrong group of notes, my bad. But we got the information we needed here, talking about its angle pairs.